Hey folks, this is Nick from First Coast Math Clinic. In this video, we're going to talk about how do you factor a trinomial when the value of a is not 1. So in one of the previous videos we made on factoring trinomials, we reviewed the general form for a trinomial, ax squared plus bx plus c. And when we factor this, we got the answer in a pair of binomials, x plus m times x plus n. But all our a values were equal to 1. So in this video, our a values are going to be either greater than 1, less than 1, and not equal to 0. So we're going to be working with examples like 2x squared plus 3x plus 7. And we're going to figure out how do we factor examples like this, because the steps you have to cover to factor something like this is a little bit different than if our a value is equal to 1. All right, let's get into our examples. All right, so our example for number 1 is 2x squared plus 7x plus 3. So first thing we want to do, we know our general form is ax squared plus bx plus c. So let's identify a, b, and c. A is 2, b is 7, and c is 3. All right, and we want to figure out our m and our n values. So we're going to draw our x. Again, this is similar to what we did in our previous factoring trinomials video when our a value is 1. So AC is going to be up here. We want two values that multiply to AC. And B is here. We want two values that add to B. So B is 7. And A times C is 6. So A is 2. C is 3. So A times C is 6. So I'll put my M value here, my N value here. It doesn't really matter what side we put it on. So two values that multiply to AC but add to B. I like finding the product first and then making sure they add up to the correct number. So I'm just going to use 6 and 1. I find it's easier to find the product first and then make sure the addition works. Because if the product works, I can usually manipulate the signs to get the addition to work. All right, so we've got our M value at 6, and we've got our N value at 1. So here's what we're going to do. We're actually going to replace our BX with M and N, because we know I can add up M and N and get that value for B. 6 plus 1 gives me 7. So I'm going to rewrite my 2x squared plus 7x plus 3, and I'm going to replace that B value here with 2x squared plus my M value, 6x, plus my N value, 1x, plus 3. All right. Now we have a polynomial, and we know how to factor this. So I made a video on factoring polynomials, and to factor this, we want a parentheses around the first pair and the last two. So I've got 2x squared plus 6x. Well, what can I factor out of 2x squared plus 6x? I could factor a 2x out of this. So if I factor a 2x, so this is, if I write this out, this is basically 2 times x plus 2 times 3 times x. So I'm basically writing out all the factors here. All right, what do these have in common? We've got a 2, an x, and an x. All right, so we're going to pull the 2x out of the parentheses. What's left is going to be x plus 3. Now, from the video on factoring polynomials, you should remember that, well, whatever is in this parentheses should be in this second parentheses. So this should be an x plus 3. Well, if this is already basically x plus 3, what am I factoring? I'm just pulling out a plus 1, right? Because I can, if I'm dividing each of these terms, I really don't want them to change. The only thing I can divide them by is 1. So now I'm going to group the terms outside the parentheses, and I'm going to group the terms inside the parentheses. And my answer is going to be 2x plus 1 and x plus 3, and that's my answer. So these are my factored binomials for 2x squared plus 7x plus 3. All right, let's get into example number 2. So number 2 is 6x squared plus 14x plus 8. Again, our general form, ax squared plus bx plus c. We want to find m and n. So a is 6, b is 14, and c is 8. Now, all three of these values are even. They're all divisible by 2, so we could factor out a 2 if we wanted to make our math a little bit easier for the purpose of this example. I don't really want to do that. I just want to work with the examples as they are, but moving further into like more complex examples, we can factor out a 2, but for this example, I'm just going to keep them as they are. All right, so let's draw our x. I want a times c and b here, and I'll put my m and n here. So a times c is going to give me 48. So I want two numbers that multiply to 48, but add to 14. So multiplying to 48, but adding to 14, that's just going to be 6 and 8. Well, that's not an 8. Let's do that. So 6 and 8. So m is 6, n is 8. So we know that these are going to be our b values, 6 and 8. So we can rewrite our trinomial as 6x squared plus 6x plus 8x plus 8. And again, we can do this because we know that 6x plus 8x is equal to 14x, which is that middle value that we have right here, right? So now let's factor out the first two terms and the last two terms. So 6x squared plus 6x. Well, 6x squared, this is just 6 times x plus 6 times x. Well, what can I pull out of here? Let me put this last parentheses in. I have a 6 and an x, a 6 and an x. We have just x plus, and we're going to have a 1 here as a placeholder, right? When we factor out, we divide by 6 and x, we're left with a 1. So we're factoring out a 6x, and we're left with x plus 1. So we know that in the second set of parentheses, we have to have x plus 1. So here, we've got 8x plus 8. So we're basically pulling out an 8x. Let me rewrite this down here. So we have an 8 and an 8 that we could factor out, and we're left with x plus, and we've got, again, a 1 as a placeholder here. So that's our x plus 1 here and here, and we're factoring out a plus 8. So now we're going to group the terms outside the parentheses, 6 plus 8, and inside the parentheses, x plus 1. So we've got 6x plus 8, and then x plus 1. So those are our pair of binomials. Those are our answers. Now, if we look a little closer at the 6x plus 8, both of these are divisible by 2, so we can factor a 2 here because we know that this is basically 2 times 3x plus 2 times 4, and then x plus 1, and then we pull out the 2. So this is going to be 2 times 3x plus 4 times x plus 1. So that's going to be our final answer right here. 2 times 3x plus 4 times x plus 1. All right. All right, let's get into example number 3. All right, so for number 3, we've got 2x squared minus 13x plus 15. So again, our general form, ax squared plus bx plus c. So a is 2, b is negative 13. So we have plus b plus c, so we're including the minus sign with our b value. All right, so minus 13. And c is 15. So again, we want to find m and n. So AC and B. So A times C, 2 times 15 is going to give us 30. And we want two numbers that multiply to 30. And B is negative 13. So multiplying to 30, but adding to negative 13, first two numbers that kind of popped in my head are going to be 10 and 3. Let's see if we can get those signs to work. Now I want it to multiply to a positive, so I know both signs have to be the same. So if I do positive times positive, I get positive 30. But if I add them up, I don't get positive, I don't get negative 13. So if I do maybe negative 10, negative 3, multiply them, I get positive 30, and then add them, I get negative 13. So I'm going to use negative 10 and negative 3 as m and n. All right, so my m value is going to be negative 10. My n value is going to be negative 3. And we're going to use those values to replace our b value. Okay? So we can rewrite our trinomial as 2x squared minus 10x minus 3x plus 15. And again, this works because negative 10x minus 3x gives us negative 13x, which is just that b value, that middle term. Okay? All right, so now let's do our factoring. Let's group the first two terms, the last two terms, and let's write this out, right? So 2x squared is basically just 2 times x minus, we'll do like 5 times 2 times x. Okay, so what do we have in common? We've got a 2, an x. Okay, so we could pull out a 2 and an x. And then what's going to stay? It looks like x minus 5. So 2x gets pulled out of the binomial, and then x minus 5 stays in the parentheses. Now, that helps us because we know that if x minus 5 is in this binomial, this set of parentheses, x minus 5 should be here as well. So let's see, how can we rewrite this set of parentheses? Maybe let's do, this is negative 3 times x. Let's think about maybe how could we rewrite 15 so we can factor out and get x minus 5. Well, I can rewrite 15 as negative 3 times negative 5. All right. Now, when I do this, I still have a minus 3, and minus 3 I could pull out. All right, that's my GCF, my greatest common factor. And I've got in common x minus 5 left inside the parentheses. There's my x minus 5, x minus 5. Okay? So I've pulled out the minus 3, and then I'm going to group the terms outside the parentheses. So that's going to be 2x minus 3, and then inside the parentheses, x minus 5, and that's our answer. All right, let's go on and do one more example of factoring trinomials where our a value is not equal to 1. All right, so for number 4, we've got negative 2x squared minus 18x minus 28. So we've got ax squared plus bx plus c, and we want to find m and n to start. So a is negative 2, b is negative 18, and c is negative 28. Now again, these are all even values, so we could divide by a negative 2 if you want to make this a little bit easier. But just to show you guys the math behind this, I'm going to keep them as they are. And we're going to include the signs, so I'm going to keep the negative 2 for A, the negative with the 18, so B is negative 18, and C is going to be the negative 28. All right, so let's find our M and N values. So start by drawing our X. We have A times C here, and B down here, so B is negative 18, and A times C is going to give us negative 56, actually, should be positive 56, because the negative times a negative, negative 2 times negative 28 is positive 56, M is here, N is here. So let's start with our multiplication. What are two values that multiply to 56? We've got, just looking off the top of my head, 7 and 8 multiply to 56. But there's no way that I could change the sign, manipulate the signs to get 7 and 8 to add up to negative 18. So I'm going to get rid of 7 and 8. Those aren't going to work out. What about maybe 4 and 14? All right, so if I do 4 and 14, 4 times 14 gives me 56. If I add them up, I get positive 18, so I'm going to have to do negative 4 and negative 14. All right, so that will work. Negative 4 times negative 14 gives me positive 56. And if I add them up, I get negative 18. So M is going to be negative 4. N is going to be negative 14. And let's substitute negative 4 and negative 14 in for our B values. So I'm going to have negative 2x squared minus 4x minus 14x minus 28. All right, and again, negative 4x minus 14x gives us the negative 18x. So we're basically just factoring out that B value, and that allows us to create our binomials here and factor the trinomial. All right, so we've got our pair of trinomials, negative 2x squared minus 4x, and then negative 14x minus 28. So let's start with this first binomial. So I'm going to break this up. We've got maybe negative 2 times x minus 2 times 2 times x. So what do we have in common here that we can factor out? What's our GCF? Well, we've got negative 2, we've got an x and an x. So we could pull that out. All right, we're left with basically just an x and a positive 2. So this is going to be negative 2x, pulling out of the parentheses, and we're left with just x plus 2 inside the parentheses. And again, that helps us because we know if we have x plus 2 here, we have to have x plus 2 here. So let's figure out how we can get x plus 2 here, right? So this is minus 14 or negative 14x minus 28. So let's break that up into maybe negative 2 times 7 times x minus 2 times... actually, check that. Hold on. Let me go back and redo that. I just realized we've got 14 and 28, so it was a much easier way to do that. So I've got negative 14 times x, and I could just break this up into negative 14 times 2 to get that 28, all right? And then we could just pull out minus 14, and we're left with an x and a positive 2, which is our x plus 2 in the parentheses. And we're pulling out a minus 14. So that minus 14 is outside of our parentheses. So we're going to group that with the minus 2x. And then we're going to group the x plus 2 together. So we've got minus 2x minus 14 times x, or negative 2x minus 14 times x plus 2. And if we want to go a step further, we can factor this out a bit more. We could pull out a negative 2. So if I pull a negative 2 out, I'm going to have x plus 7 times x plus 2. So my final answer here should just be, we write everything up here, negative 2 times x plus 7 times x plus 2. All right, and that negative 2 is the original, like, kind of negative 2 we could have factored out at the first step that I didn't really want to, because I wanted to show you guys the math with the full set of values. Okay. All right, so this was a video on factoring trinomials where our a value is not equal to 1. If you like this video, leave a like, comment, and subscribe, and you can check out the video that's going to be linked at the end of this one. The card for the video is going to be on factoring trinomials where a is equal to 1, so check that out. And guys, make sure you're subscribed and leave a comment for some videos you would like to see made. Hope these videos are helping you guys. First Coast Math Clinic. Hey folks, this is Nick from First Coast Math Clinic, and this video is on how to factor trinomials. In this video, we're going to factor these 5 trinomials. This is a good video if you're just starting with factoring trinomials. So for our